This is a continuation of the mystery problem that we set up yesterday, wherein you picked a month and a day. I asked you to perform some operations and tell me what we called the secret number. And then from your secret number, I was able to figure out what month and day you started with. The interesting thing here is that you have two inputs, and yet from one number, I was able to figure out what both of those inputs are. What I've asked you to do is take a look at, we have a very, a small sample to work with. We have this small sample to work with, but we want to make observations about the small sample to work with. The other thing that you could do is just pick another month and a day, follow the steps, and see if your pattern holds. And you could speculate about how to go from the secret number to the month and the day. Then the next thing is, why does this work? Why does this secret step take us from the secret number to the month and the day? So after you have how you get the date based on this, the question is, so why does it work? So the first step is to figure out how things are going. First step is to figure out how we do the thing. The next thing to figure out is why the thing works the way it does. And that's why we have this mystery. We have these two questions. So to summarize, the steps that I asked you to do, once you pick a month and a day, I asked you to first multiply the month by 2. Then next, add 7 to the result. After you add 7 to the result, multiply that result by 50. Then add the day to the result. That's the day that you picked. And fifth, we subtract 365. And that's what your secret number was. And then what I wanted you to figure out was some secret math step that goes from the secret number, do a thing, to go from secret number to month day. So at this point, you want to do a thing, do some secret thing to go from the secret number to a month and a day. All right, so that's the first thing you need to figure out. Then you need to explain why this works. When you make an observation about how something is working, that's when you go to the discussion and suggest it to everybody else. Say, hey, here's one thing I have observed. Like we see in the chat, Emily has observed, you're noticing that April 24th is 409. So 409 goes to April 24th. And 809 went to August 24th. So we're making observations. We're just taking notes. This is that part of a clue where we're saying, I've just seen the little card for Colonel Mustard, so it was not Colonel Mustard. So we'll make some observations. So 409 is April 24th. 809 was August 24th. And then it looks like, based on your comment, that you did March 24th and found 309. So we have these two observations, 409, April 24th, 809, August 24th. Then a good way to see if, to test your speculation is to just pick a date that we haven't covered, run it through the process and see what we got. So maybe we try March 24 and see what that gives us. And it looks like you did March 24 and came up with 309. So maybe there's something going on here. These three observations, what do they suggest? So 409 is April 24, 809 is August 24. We try March 24 and we got 309. Let's double check that to make sure that it's okay. Take the month 3 and multiply by 2, add 7, multiply by 50, add the day, and subtract 365. So March 24 does in fact lead to 309. So what does this suggest? We've made some observations. Now let's form a hypothesis. We've made some observations, we've only got 3, but pretty strong. So let's make a hypothesis. So based on our observations, we speculate. What is it about the observations? And what does that suggest so that we can form a hypothesis? We need to form a hypothesis. So if 409 is April 24, 809 is August 24, and March 24 is 309, what does it look like we're forming for a hypothesis? Don't worry about, but what about this, but what about that, but what about this? What is this suggesting to us? So what is this suggesting to us? Looks like the 100s corresponds to the month. So that's a great observation to make. Month is 100s. So that's a great observation because 409, April, 4, that's the 4. The 8 in the 809 corresponds to August. The March gave us a 309. So it looks like the hundreds are increasing with the month. Are there any counters to this? That certainly happened in these 3. Are there others that either support this or go against this? So is there any counter to the fact that the hundreds digit is the month? So there is, and what's a counter to the fact that the hundreds digit is the month? Because it worked in this 4, the 8, and 3, April, August, and March, but October in 986 gave us October 1st. But I was being a little bit unfair because you said the 100s increase with the month. And I took that as to observe that the month was the hundreds digit. And then, so notice that in that 986 is October 1st. So note 986 corresponds to October 1st. So maybe the hundreds isn't the month, but it does increase with the month. So that's an important thing to be able to do. When someone misinterprets what you said, say, "Oh, that's not what I meant. Let me clarify." But the hundreds digit does increase with the month. So we should clarify that. So the October thing, the 986 gave us October 1st. So we have a 9, which would suggest September, but we end up with October 1st. We should also note that 986 is not going to be September 86th, because September September has 30 days. So September 31st could have been like on October 1st. But then that would say 931, not 986. So there's something else going on. But it does appear that the hundredths digit does increase with the month. March gave us a 3, April gave us a 4, August gave us an 8, October ended up with a 9. Also, June gave us a 587, gave us June 2nd. So there's another counter to the fact that the hundredths digit is not just the month. 587 gave us June 2nd. Let's see, anything else? Let's see, 293 gave us March. There's a 2 in the hundredths digit and they gave us March. But the 100ths digit does increase with the month. So there's an observation that we can make. Based on the original 3, based on this observation, 409 is April 24, 809 is August 24, 309 is March 24. What's another observation we can make? So we've observed something about the hundredths digit increasing with the month. Is there anything else you notice about these 3 observations together? So each of them have the same day. It's all a 24th, a 24th, and a 24th, and the ones digit is all the same. A 9 in the ones digit corresponds to a 24 on the day. So there's another thing to speculate. The 9 in the ones digit it looks like the ones digit 9 corresponds to a day of 24. So we do have some things that where that doesn't work. Actually, no, we only have these 3 with the 9. So we can test this hypothesis. Let's pick some other month with a day of a 24 and see what number that leads. So this is a test, this is a hypothesis we can test. We can test this hypothesis. All we have to do is pick some more month with a 24, pick some more 24ths and see if they end in a 9. Pick more 24ths. And see if they give you a 9. So we'll pick more 24s and see if they give us a 9. So now we have to do some science. And so maybe we'll pick July 24. And maybe we'll pick December 24. The point is that we have landed on something that we can test. A very specific thing, a ones digit of 9, it looks like that might correspond to a day of 24. We've got 3 pieces of evidence. There are 12 available. We could just run through all of them and find out, because that's not a lot to do. So you could test July 24, test December 24, test various months, January 24, and see if they end in a 9. So that would be a good place to start. We've made an observation. The hundredths digit does increase with the month. And then we've got this connection between a ones digit of 9 and a day of 24. Does that hold in other examples? That's a hypothesis we can test. Once we've made this observation, we maybe convinced ourselves that the 9 always leads to a 24. We can start to form a hypothesis after some testing, or we could start to refine our hypothesis after some more testing. So this will lead to new observations. And new observations leads to more testing. And that's just how science works. We make some observations, we form a hypothesis based on our observations, then we devise a test to see if our hypothesis holds. Based on those new observations, we make a new hypothesis or refine our old hypothesis, and then we design more tests to see if that works. And then we just continue until we've answered the question. Any questions? Can you tell which questions I'm not going to be answering today? Because that's part of what we're doing. So I want you to make use this observation. That's a good one. That's a good one. I'm glad you suggested this one, so thanks. The 9 and the 24, there's a connection there. Or is there a connection there? Let's find out. And we'll have to find out together in the discussion section. And that's what I want. That's what I want in the discussion. Any questions? Comments? And deep thoughts? All right. While we're thinking about this, I want to make another observation. I know we're supposed to be reading expressions, and I promise this does actually have to do with reading expressions, although I spelled 2 wrong. Here, I'll have to go Roman. All right, that's as far as I can count in Roman numerals, because Roman numerals don't make any sense. They make sense, but they form a terrible system. I'll put it that way. All right. Let's list the multiples of 9. Let's list some multiples of 9. So what's 9 times 1? And 9 times 2? And 9 times 3? And 9 times 4? I'm going to write all the way up to 9. So 1, 2, 3, 4, 5, 6. Next is 7, right? So what are the multiples of 9? 9 times 1, how much is that? I'll do the hard one. 9 times 1 is 9. What's 9 times 2?
18.
18. 9 times 3?
27.
27. You guys are good at the waiting game. 9 times 4 is 36. And then 45. And then 54, the old switcheroo. And then 63. And then 72. And then 81. And then 90. So if we imagine the tens digit of the 9 is a 0, notice that the tens digits count up while the ones digits count down. So that's kind of a cool thing to notice. You may or may not have been noticed that before. So let's notice some things. We're just speculating here, so let's notice some things. The tens digit counts up. And the ones digit counts down. So this is kind of interesting. The tens digit counts up and the ones digit counts down. So you may have seen this trick to multiply on your fingers. So let me switch cameras. So this is actually useful with the tens digit counting down, or sorry, the tens digit counting up and the ones digit counting down. If you put your hands up, my camera's reversed and I can't see. There we go. And if we wanted to do 9 times 3, if you just count from one side, go count 1, 2, 3, then we get 27. 27, because 9 times 1, 2, 3. If you put that finger down, just count over from your thumb. If you do 9 times 1, that's nothing over here, and 9. 9 times 1, 2 is 1, and then 8, and then 8. I have my camera inverted, so everything is backwards. 9 times 1, 2, 3, 4 is 36. Has anybody ever seen the hand trick for your multiples of 9? It's pretty cool. And part of it is based on when you count up in the tens digit, you're counting down in the ones digit. So when you do that on your hands, since you have 10 fingers, I apologize for this being a very ableist thing, but if you have 10 fingers, if you're missing a finger, then you're going to have to count in base 9 instead of base 10, but it'll still work. But when we count off and hold a finger down, it's going to count up the tens digit, but count down the ones digit in the same amount. So that's something interesting to notice. The tens digit counts up and the ones digits count down. Here's another thing to notice. With each of these multiples of 9, let's consider what's called the digital sum of the number. The digital sum just means add the digits. If I find the digital sum of the number, so if I do 0 plus 9, we get 9. If we find the digital sum of the 18, 1 plus 8, we get 9. The digital sum of the 27 is 2 plus 7 is equal to 9. The digital sum of 36, 3 plus 6 is equal to 9. And you can see where this is going. 4 plus 5 is equal to 9. 5 plus 4 is equal to 9. 6 plus 3 is equal to 9. 7 plus 2, do we know what it is? 9. Actually, yeah, it's 9. 8 plus 1 is 9, and 9 plus 0 is 9. This is actually a test to see if a number is a multiple of 9. If the digital sum of a number is a multiple of 9, then the number itself is a multiple of 9. It just happens that when we have these 2-digit multiples of 9, the digital sum is always just 9. But this generalizes. If the digital sum of a number is a multiple of 9, then the number is a multiple of 9. If the digital sum of a multiple of 9, if the digital sum of a number is a multiple of 9, then the number itself is a multiple of 9. This is a cool way to find out if a number is a multiple of 9. It's also a good way to find out where's the next multiple of 9. So for example, 3,158. We want to know if it's a multiple of 9. If we add the digits, the digital sum is going to be 3 plus 1 plus 5 plus 8. So 4 and 5 is 9, and 8 is, I lost track. 8 and 5 is 13, 14, 15, 16, 17. 17 is not a multiple of 9. Did I do that right? Yeah. 17 is not a multiple of 9. So 3158 is not a multiple of 9. So 17 is not multiple of 9. So 3158 is not multiple of 9. And we can check that on a calculator if we want to be just basic about everything and boring. 3158 divided by 9, nope, it didn't work. But when we're looking at the digital sum is 17. The next multiple of 9 is 18. So if we went to 3159, that is a multiple of 9. So that's where we can extend this. Not because it's a useful thing, but because it's an interesting thing about the number 9. But 3159 is a multiple of 9. Because it's going to take that 0.8 repeating, that 8 ninths, and we'll add one more ninth to it. So if I do 3159 and divide by 9, 351. So, interesting thing about the number 9. It's also true for 3s, which makes sense because 9 is just a couple of 3s multiplied together. So, of course, they're going to be working together. I mean, if you're the math cops and you're going to go arrest 9, go and arrest 3 as well, because they're going to be involved. It's going to be involved. If there's multiplication running around, if 9's responsible, 3 is also responsible. Because 9 is just 2 3s stacked together. It's like kids that want to get into an R-rated movie. They just get a trench coat and stand on each other's shoulders to look like an adult. It takes 2 of them, 2 3s. Then there'll be 1 9. They're old enough to go see the movie, at least in math land. So we have this interesting fact about multiples of 9. Notice that if we take a number that's not a multiple of 9, the digital sum will not be a multiple of 9. So I'm going to pick a smaller one. So let's, for example, let's consider the number 57. I usually pick 57 because it's a saucy number, so I like this one. So let's find the digital sum. Five plus 7 is equal to 12. 12 is not a multiple of 9, so 57 is not a multiple of 9. 12 is not a multiple of 9. So 57 is not a multiple of 9. Twelve is not a multiple of 9. The digital sum of 57 is not a multiple of 9, so 57 is not itself a multiple of 9 either. However, we did learn some information about this by finding this 12. So 12 is the digital sum. It's not a multiple of 9, so 57 is not a multiple of 9, but there is a multiple of 9 hiding in this 57, and the mask it wears is its digital sum. If we subtract the digital sum from the 57, let's see what we get. So the 12, the digital sum, is the mask that the non-multiple of multiples of 9 wears. If we take 57 and subtract the digital sum, 57 minus 12 is how much? And 45 is a multiple of 9. 57 is not, but if you subtract the digital sum, you will get a multiple of 9. So a not multiple of 9. if you subtract the digital sum, in this case, we end up with a multiple of 9. This works for any non-multiple of 9. So let's see, 88 minus 8 plus 8. That's 88 minus 16. 8 minus 1 is 7. 8 minus 6 is 2. Earlier, we had 3158. We know that 3159 is a multiple of 9, but also if we take off the 17, if we take the 3158 and subtract the 17, the digital sum, so 50 minus 10 is 40. 8 minus 7 is 1. And then we check 3 plus 1 plus 4 plus 1. That's 4, 5, 6, 7, 8, 9. Oops, I shouldn't put an exclamation point. Because then it's 9 factorial, which is a completely different number. Any questions? So sometimes people use this fact to ascribe mystical properties to the number 9 and the multiples of the number 9. And then they start looking, and then they consider this to be either lucky or unlucky, and it can be either one, because if you decide that this is a lucky thing, you will go out and find where it's a lucky thing. If you decide that it's an unlucky thing, you'll go out and find that it's an unlucky thing. That is to say, whenever you're dealing with mystical properties of numbers like numerology and stuff, if you want to find a pattern, then you will find a pattern. 13 is not inherently an unlucky number, but people will believe it is because we'll register when 13 is associated with an unlucky event. But at the same time, we're ignoring all the times that 13 has no association with bad luck. You ignore those in favor of the ones that are reinforcing your belief. That's why it's important that we study math, because we don't want to be fooled by these things. We like to think that facts will defeat our beliefs, but in reality, it's the other way around. We will ignore facts and evidence if something comes after something that we think we believe. That make sense? It's not magical. And this still does have to do with reading expressions. What we want to do is analyze what's going on in the secret number month and day problem and what's happening with these digits of 9 with expressions. We want to apply algebra to this so we can get rid of all these mystical things. We want to refine our hypotheses so that we can figure out what's going on and not be amazed by these things. Because as long as we're being amazed by these things, we're going to miss out on some things that are actually amazing. That's why you shouldn't learn the secrets of magic tricks. Even if, because once you know how to do it, you missed out on something. And when it comes down to math, math is highly weaponized and used against you constantly. It's really important that we understand math because math has been weaponized and used against us. Any questions? So, in addition to the discussion where you're trying to figure out the mystery and solve the mystery of secret number to month and day, I want you to look at examine the mystery of the digital sum and the number 9. Then I also want you to be on the lookout for instances of math being weaponized to be used against you. Any questions? Comments? Snide remarks? I actually need to amend that last one. It's more than just look for instances of math being weaponized against you. Pay attention to the times that you start using math as a weapon against someone else. So as soon as you start saying, well, why don't you just look at the numbers? Then you will agree with me. You better look at your numbers to make sure if they agree with you, or if you're manipulating them to enforce your beliefs on someone else. Does that make sense? It's probably the most important lesson of this entire class. And it's why I do this lesson every class, not with the 9s necessarily. Look for instances of math being weaponized against you, and pay attention to yourself so that you're not weaponizing math against someone else. All right, that's going to do it for today. We'll talk more about, we'll go over the results of any hypothesis testing that you do on our secret number problem tomorrow. That's it for today. I'll see you all on tomorrow, and thanks for playing.